Welcome to Hartman Math. This is lesson 5.4, Polynomial Division. So we're going to approach this very similar to regular long division with just a couple modifications. So let's say we're looking at this problem, example number 1, divide this polynomial by this polynomial. So we want to set it up as a long division problem. One thing we got to look out for, okay, in the dividend, what we're dividing into, not so much here, what we're dividing into, is if it has any missing terms. So if you notice, it's got x to the third. The next thing we should see is x squared, but it doesn't have that. So we have to account for that when we write up our division by putting a 0 placeholder. So as you can see, we put the x minus 3, the divisor on the outside. Here's our dividend. We put the plus 0x squared as our placeholder there. So anywhere inside where there's a missing 0, after the first term, we need that. All right, so now what we're going to look for is first term here and first term here, essentially dividing this into this. But the way you want to kind of rethink and rephrase that in your mind is, what would I multiply x by to get 2x to the third? We would say that's going to be 2x squared. We're going to put that up on top. And I like to put it in the column where it's x squared. So we have an x cubed column, x squared, x, and constant. So we put it right here. Now, like we would in a regular long division problem, we take this and we multiply by our divisor. But this time this is a binomial, so we need to make sure we distribute. So distribute it, stack it underneath when we get the multiplication. So 2x to the third minus 3x squared. I'm sorry, minus 6x squared. Now, the tricky part is now we would subtract like we would normally do in regular long division. But it's tricky with some of the signs, so we got to be careful here. So we go this minus this, that should cancel. And be careful, we don't want to add here. It's 0x squared minus negative 6x squared. Minus minus becomes plus, so this is going to be a positive 6x squared. And you can put the plus sign if you want to. I kind of like that. So again, we are subtracting 0 minus negative 6, 6x squared. And then once you're done with the subtraction, bring down the next term. And then we just repeat the process. First term, first term. What would we multiply x by to get 6x squared? It would be a positive 6x. That goes up on top. Distribute. Stack it underneath. Subtract. 6x squared minus 6x squared cancels. Negative 3x subtract negative 18x. Don't add. Minus minus 18x becomes plus 18x, so we get a 15x. Positive. You want to put the plus sign. Bring down the plus 5. Repeat the process. What would we multiply the first term by to get the first term? Positive 15. Distribute. Subtract. Again, we got this minus minus thing. So 5 minus negative 45 is 50. Positive. Okay? So how do we then, since it didn't, we got a remainder, how do we write that? We're going to write it as a fraction. You must, though, have an operation sign after this. Since this is positive, we're going to put plus 50 over the divisor, what we were dividing by. And that's our quotient. That's our answer to this division problem. If this had been negative here, we got a couple options. You can always put plus and then put the negative 50 there if it was negative. Or you could just take the minus and put it out in front as minus 50 over. But you have to have an addition or subtraction sign here. Without it, okay, unlike we would do on like maybe 1 2/3, without it, it means this times this. So we need to have that there. All right. Go ahead and pause the video here and try to divide this into that. Pause here. I'll see you in a moment. All right, so we can set this up. This doesn't have any missing terms, so we don't have to do a plus zeros, anything like that. So we can just set it up regular. And it's going to look like this. What times what is that? 3x. Distribute. Subtract negative 2x. Subtract a positive 12x is negative 14x. Bring down the 6. Now, x times what is first term? Negative 14. Distribute. Subtract, cancel, we get positive 62, so plus 62 over our divisor, quotient, there it is. So the next thing we're going to look at is what use does polynomial division have? And here's one of the uses. Looking for zeros of a function. We've seen it before. If we could just regular factor, whether it's factor double bubble or factor by grouping, whatever. But some of these don't necessarily factor in that way. So this is what's going to help us. So looking for a zero of the function, it's any value, any number that makes the function equal to 0 when you plug it in. That's the definition. Okay. Going along with that is the factor theorem. So if k is a 0, then turn that into a factor. X minus that number is a factor of our function. And we're going to need to do that to find other factors and find the zeros. So what that means, the factor theorem means, is, since it's a factor, that this x minus k is going to divide evenly into our function f of x. And that's important. So we're going to see what that looks like in an example. So we're going to get problems that look like this. We're going to get a function f of x. And we're going to say, hey, this is a 0. If we wanted to verify it, you can plug it in, and it turns out to be 0. That's not part of the problem. It's not really going to help us. They've told us a 0. It's okay to believe them. Find the other zeros. So we're going to go back and look at the factor theorem. If we know a 0, then x minus that number is a factor. So since 6 is a 0, that tells us that x minus 6 is a factor. And factors divided evenly. So let's turn this into a division problem. There's our factor. We divide in evenly, so let's do the division. So go ahead and pause here, practice the division. I'll let you know, because it's a 0 and therefore that's a factor, you have to get 0 as a remainder. If you do not, you either done the division wrong or you got your factor wrong. Got to get 0 as a remainder. So go ahead and pause here. Go ahead and do the division. All right, what we should have come up with, x squared plus 3x plus 2, after you've done the division, and the remainder was 0. So that's now a factor. If we're looking for zeros, we can set it equal to 0 and solve this. And once we're down to a quadratic x squared, back in Unit 3, we have lots of practice on that. Whether we do factoring, square root method, complete the square, quadratic formula. Let's try factoring. So it does become x plus 2 times x plus 1. Set it, split them up, set them equal to 0. Solve them. X equals negative 2, x equals negative 1. Those are the other zeros. And you can have them be in this notation, or you can have it be in this notation. Either is fine. If you want to check your answers, you can plug those in separately. Plug in negative 2 into all of them, you should get 0. Plug in negative 1 into all of them, you should get 0. But these are the steps. When they gave us a clue, turn that into a factor. Divide it into the polynomial. The quotient, make sure you get 0 remainder. The quotient, set it equal to 0, and solve by some method. If this had been negative 6, we would have done x minus negative 6, and that turns into x plus 6. Okay. Example number 3, let's do one more of these. So we're given a 0. Let's turn that into a factor, x minus negative 1, which becomes x plus 1. Let's divide it into our polynomial. Because it's a factor, it needs to divide it evenly. Once again, go ahead and pause here, do the division, make sure you get a 0 remainder. We should have gotten x squared minus 5x plus 8, 0 remainder. Set that equal to 0. We could try to factor, but I don't think it does. I don't want to divide that by 2 and square it and get a fraction, so let's do the quadratic formula. Okay. Maybe go ahead and pause here again, see if you can do the quadratic formula and see what comes out of that. Let's see what happens with the quadratic formula here. Opposite of b, plus or minus. We're going to get inside 25 minus 32, negative 7. Square root of a negative, we know that means out comes I. So our zeros are x equals the fraction 5 plus or minus I root 7 all over 2. Those are the other zeros. That's it for today. I'll see you next time.